Okay, I think we're going to start just about right on time. First of all, thank you everybody for coming. This is the art of the font. Let's see, little agenda. We'll talk about the motivation, talk about fonts and their history, fonts in Apple, core text, TextKit, dynamic type, and then some closing thoughts. So introductions. I'm Ayal Spitz. I'm a senior principal software engineer. Oh my goodness, it's a mouthful. Basically, it means that if I let my beard grow out, I'm the gray beard in the audience. I work for we were Intrepid, a little kind of tiny studio. We got inhaled by Accenture, so now I officially work for Accenture. Let's get right into it. So I've been doing software for about 35 years now, and I've always been interested in our process of developing code. How do we write code? Why do we keep doing it? I mean, essentially, we keep doing the same thing, right? We write code, we compile it, we run it, we see what happens, kind of wash, rinse, repeat. We keep doing the same thing, and this hasn't really changed in a long time. I mean, if we go. If we take somebody from the 1940s, we bring them forward, a developer from the 1940s, and we bring them forward, sit them down in front of a new machine, right? Other than questioning as to why exactly we brought a developer forward as opposed to somebody famous or such a thing, they will be really amazed by the performance of our computers, but they'll get to it pretty quick, right? It hasn't really changed a lot. And so every once in a while, I kind of get really excited. I'm like, you know what? I'm going to solve this problem. I'm going to I grab a copy of Lexiniac. I'm like, I'm going to write my own language. I'm going to change this all. I'll grab a copy of FlexDevice. Every couple of years, I get into it. So every couple of years, the books get kind of newer. I jump into Apple, and I'm going to do this. This is going to be great. I'm going to solve it. And recently, I actually did that again. I'm sorry, it's not as legible as it could be, but I wrote a little app for kind of building apps on the iPhone, because I was like, you know what? I end up sitting around a lot of times in different venues at the airports and stuff like that, and I'm like, you know what? I'm gonna write code so I can write code at the airport and stuff like that. And as I was doing that, I kind of went, it's not really the language. The language isn't really the problem. It's more kind of the IDE, the development environment, how we write the code. I said, okay, well, kind of came to that white rabbit moment where I'm like, this is one of those white rabbit moments where you could follow this down kind of that tunnel and see where it takes me, or kind of put it aside and go, yeah, it's okay, somebody else will solve that. I said, you know what? I'm following the white rabbit. So I started trying to build a little programming environment. I tried to kind of lay out the text the way I wanted to do it, and I was running into difficulty. When I started this, core text was the only real way of kind of interacting with the text. And I said, I wasn't getting kind of the results I wanted. It wasn't really doing what I wanted. And so I actually wrote this, which dove all the way down to trying to get the glyphs and rendering the fonts myself. And that was one of those warning signs where I went, that rabbit hole got really deep, really quick. Oh my goodness, okay. I said, this is really interesting stuff. I mean, rendering these fonts made kind of really interesting kind of discovery for me. So I said, I remembered that Steve Jobs, when he talked about the Mac and where the ideas for all the fonts for the Mac came from, he pointed to a calligraphy class at Reed College. And I went searching in through calligraphy, and I found, it means beautiful writing. I was like, so this is really connected to writing. Fonts are connected to writing. And I started digging into that. As you can see, the rabbit hole goes deeper and deeper every time you turn around. So I said, this all leads to written language, and that's really kind of our font. You could almost call it font 0 or font 1. You look at languages like Hebrew, you get this beautiful calligraphy. You also, though, get these kind of square characters and cursive characters. We look at languages like Arabic. Again, you get very nice characters. You get these calligraphy characters. They're beautiful. But they're all, at that point, they're pretty much unique to each writer, right? Each person writes a character. It's unique to them. Hard to replicate. Mass replication, I mean. But you do get these beautiful calligraphy. So, sorry about that. Pressed the wrong button. You get these books, they were producing books at these times, but each one was handwritten, right? The one here on the left, I think is a Bible. You can see it beautifully illuminated. But all the characters, they're hand done. If you make a mistake, the next book is not nearly as going to be exactly the same, right? It looks slightly different. This book here, I believe, is in Hebrew, and it's a technical manual. Amazing to discover this stuff. So it's like, oh, okay, well, what comes next? I thought it was printing press, but no, in fact, the next thing was wood block. Basically, you carve out the negative space. You're left with these kind of raised characters. This is very popular in China. Roll ink over it, press it down onto a piece of paper, and you have your first printed page. And it's really neat if you look at these. These are, amazingly intricate. But the problem is now if you made a mistake, you either have to do the entire thing over or just live with it. So this can be, you can kind of think of this as maybe font 1.5. We've taken kind of that handwriting font, converted it into these characters. Now, I thought that fonts and so forth, the origin really started with the Gutenberg press. But it doesn't. It turns out that the Chinese were doing movable type long before Gutenberg. Now, these are characters here. What you're seeing, these are characters, they're made out of clay, and they're gorgeous. And it was the same kind of general idea as the Gutenberg press. You had these clay characters, you put them together, roll ink over it, stamp the paper or fabric or whatever you were wanting to print on. Then we get to Gutenberg press. Now, the problem with Chinese characters, movable type, why didn't it take off? Because they were clearly way ahead, was because there's thousands of characters that you had to create. And so it made life that much more difficult. With Gutenberg, his big innovation was the creation of the metal type, the stamping capability, the movable type using metal. This took off remarkably well in Europe because you had a smaller subset of characters, right? You only had about 100 plus or minus. So it was really easy to go out, start producing these are samples of the punch characters here. It was really easy to do this. Well, easy is a relative term, right? You had to have a foundry to start producing these. And in fact, that's the origin of the name Font Foundry, right? These were literally foundries that were sitting there producing these fonts. One thing, though, to recognize is as we move to this kind of production of books, and here's one of the famous books, the Gutenberg Bible, you can see the characters are all beautifully aligned, they look very nice, they're symmetric. But one thing to kind of recognize is that we lost some of that beauty of the calligraphy as we kind of drove forward into this mass production. But still, we've got some beautiful illuminations to go on here. It's very nice. And this is kind of the foundation of what we consider today our modern fonts, right? These kind of constructions, these characters. So let's go to Apple. That's kind of the next big step, at least for me, was the next big step. I wasn't running a Gutenberg press, so. Apple II had one of these. This was the state of the art in fonts. These kind of square green characters. If you were lucky, maybe they were orange or another color. If you're on IBM, I think they were very much green. I'm trying to remember, unless you got an orange screen. But this is what it looked like. And we kind of circled back to the Macintosh now, right? That step forward. Steve Jobs talking about calligraphy. So this is the original set of Mac fonts from OS 1 to OS 9. All but Venice were done by Susan Carr, who you should know is responsible essentially for all the basic elements of the Mac OS, basic UI elements of the Mac OS. Let's not go too far. Venice, for some reason, was done by Bill Atkinson, who is also well known for having done all these different components of the Mac, including Mac Paint, which this is kind of rendering here. But these are all bitmaps. So if you wanted a different size font, you had to sit and draw the different sizes. They tried to play some games with math and so forth, but at the end of the day, if you wanted a bold version, you wanted an italic version, somebody had to sit and draw all these characters out. About that time, Adobe, so this is 1980, 80s, mid-80s, Adobe put out something called PostScript. I'm sure all of you know about PostScript, right? Basically it's a description of a page independent of resolution. It's all vector-based. It's beautiful when you have a laser printer, 300 DPI, 600, 1200. We've gone crazy these days, but PostScript makes it look beautiful. Well, if you're going to do beautiful high-resolution images, you kind of need high-resolution fonts. So they created PostScript type 1 fonts, which are describing each character as a series of vectors. So you can see now where you have your bitmap here, right? You start trying to stretch out to bigger resolution. No, it doesn't quite do that job. PostScript, though, gives you these beautiful characters. And for the longest time, Adobe kind of kept it to themselves. The hinting was the important part. When you shrink characters, you want to maintain certain attributes of your font, because you don't want to lose, like if you have an eye, if you start shrinking and shrinking and shrinking, at a certain point it becomes smaller than your pixels or your line, your dots. So they had hinting to basically say, no, if you go to a certain point, you can't go beyond like a straight line for your letter I. It has to show up. But they kept that secret. That was secret sauce that they didn't share with anybody. So of course, Apple's not satisfied being kept out. They like to kind of control their whole ecosystem, more or less. So they started working with, they started developing TrueType, which was basically an answer to PostScript font type 1. They started building it. They actually ended up sharing that with Microsoft, as many of you may remember. Some of you may remember. I keep forgetting. It's amazing. Time flies and you're like, oh my God, yeah, of course this. And you turn to certain developers and they're like, I don't know what you're talking about. I wasn't there. So, like, unfortunately, I was. Or fortunately, I don't know. I love doing this stuff. So anyway, TrueType comes out. Suddenly your machine is able to produce these beautiful fonts on your screen, scale them to different sizes. You don't have to worry, did you buy the 9-point version of the font or the 12-point version? It scales beautifully. It looks beautiful on the screen. So, of course, at a certain point, Apple goes, yeah, we got this. We're good. And they came out with something called TrueType GX. And Microsoft said, great. We want TrueType GX too. And Apple said, no. We're happy where we are. Thanks for coming. You were great while you were playing with us, but we're okay. So, of course, Microsoft said, no, we can't have Apple controlling this market. Adobe controlling this market. So they started developing OpenType, which probably many of you use still today. It's one of the most popular ways of distributing outline fonts. And in the enemy of my enemy is my friend, they actually ended up working with Adobe to develop OpenType. And so if you go to the OpenType site, this was the best image I could find to represent OpenType, which is kind of disappointing, but I was like, oh, okay. And it's amazing. These fonts have so much information in the file. If you ever have an opportunity to take a peek, I would recommend just taking a peek. Much more than that, if you need some material to fall asleep by. These documents talking about OpenType, TrueType, and Type 1 fonts is phenomenally large. You'll start into it, and the next thing you know, you're off in La La Land. It's quite nice. So, of course, Apple hasn't stopped. They now have something called Apple Advanced Typography. And it turns out that Zapfino is actually one of the more advanced fonts in the Apple array of characters, or array of fonts. This is typing in text editor. You'll notice as it's typing along, the characters are changing to the linkages, the connections between them are kind of coming together. I did not realize this until I was digging into it. I'm like, whoa, that is very cool. And the cool thing is it's in text editor of all places. I was like, really? It's available in other places, but text editor has it. So if you dive into the fonts menu, go to the little settings kind of wheel over there, typography, you'll discover this entirely new menu, essentially, of all of these different capabilities of the font. And if you'll notice here, glyphs. Many of the glyphs in Zapfino have variants. So you can choose that if you liked this original, let's replay that. If you like that style Z, or you like the giant swooping Z that comes up at the end, you can actually go and pick that and change the way it looks. It's phenomenal. So, Apple Advanced Typography is actually the underpinning of, I believe right now it's it's the underpinning of the typography you'll find in macOS and in iOS. OpenType is still supported, of course. You can load up OpenType fonts. So let's talk about core text. If you can avoid it, do. Seriously. I went diving through that briar patch. There's a lot there. There's a lot of power, but it's also very it's not the easiest way to get to things. So in iOS, pre-iOS 7, the way that the world looked for iOS developers was that all our type stuff was primarily sitting either on top of some special string drawing routines or on top of WebKit. And if you wanted to do special things, you had to go down to core text. This is what I had to do in order to render that first series of fonts you saw there, that little typing animation. And this just goes to show you how complex it can be. What I did was I extended character to be able to get me the glyph. Now, character and glyph, a lot of people may confuse them as being one-to-one. They're not. Right? Characters are the basic kind of writing elements of a language. Glyphs are a representation of that. But here's the thing. You can have more than one glyph represent a character. There may be several of them, as we saw with the variations before. The other thing is that a glyph may represent more than one character. So for example, when characters are tied together by ligages, you get a single glyph for multiple characters. This code here dives into core text, and it actually, if you see, you can see it. I'll be posting these slides, so if you can't read it right now, trust me, it's there. I will post them. You can read this all. I tried to make it a little bigger. But in any event, it's actually taking an array of characters. So I take the single character, put it into an array, hand it off to get the glyph for that one character. Then here in the second extension, so the first one is extending character, the second one is extending CT font. Here I'm actually getting out the path, the actual path for the font, the outline of the font. And so again, we're extracting the character, getting the character, the path, the CG path for it. And then this final extension here extends UI font, and it basically draws out the character. I actually convert them to Bezier paths, easier for me to work with, my personal preference. But I've also changed them into images. This code here, the final function over here, actually takes character and gives you an image. I found that really useful. It's almost like creating a movable type, right? You just stamp the character wherever you want it to be. And that's very useful, instead of trying to draw and draw and draw. So, can anybody tell me what's wrong with the picture on the left? Or why the picture on the left doesn't look exactly like the picture on the right? Any ideas? Sorry? Looks like overstrike. In a way, it kind of is. So what happened is I got these outlines for the different glyphs, and I started punching them down kind of. And I went, oh, good. And I suddenly noticed that they were just that much darker than the characters I would get using just the standard UI text layer, text view. I couldn't figure it out. And I was like, I got the same character. It's the same. the hinting was fine. Everything, you know, the character shapes looked fine and so forth. I'm sorry? It's exactly it. I was stroking the path instead of filling the path. So it's important to remember that what you're getting out of core text as far as the path for a character is the outline of it. So the moment that I switch to filling the outline as opposed to stroking it, ta-da, it looked like what I actually thought it should look like. So that was very cool, and I was very excited. So let's move on. TextKit, starting in iOS 7, Apple graced us with TextKit. So now all of our different labels and text-oriented elements, we're using TextKit. Of course, UI WebView is still using WebKit to do its work, but now you don't actually have to touch core text for the most part. Apple gives us this really nice kind of architecture of a text view, a text container, a layout manager, and text storage, and of course, to go with them, they provide us with classes for each one. And the neat thing here is that you don't actually have to change much to get what you want. So for example, if you just want to, for example, highlight text as the user is typing it, or react to the fact that they've typed some interesting characters, for example, the app plus some name, you just have to extend NS text storage. Or if you don't like the container, you don't like squares, you'd rather have some interesting other shape, you just have to extend NS text container. This is a simple example of that here. NS text storage, this is almost boilerplate. You have basically one property, which is the string, being able to just return, here's the content. It's without any decoration. The attributes, basically if I'm looking at a specific area of the font, of the text, what are the attributes associated with it? And then replace character and set attributes. You could copy this and be very happy. It doesn't require any additional. And here, this final function, this is where if you wanted to make changes on the fly as the user is typing, you would add your code right here under process editing. And you could have all your regular expressions or whatever mechanism you chose to use to change the way the text looks. If you'll notice, for each one of the two functions here at the bottom, the replace characters and the set attributes, we've got a kind of pretty straightforward pattern. We begin editing, we make our edits, we then we say edited, and then end editing. This essentially lets the rest of the system know that you're making changes, not to do anything until you're done. I talked about the fact maybe you don't like your square container, rectangular container, it's boring. All you have to do, NS text container, you really just have to override this line fragment rect. And that's it. You can use that to change any shape you want. In my case here, I'm using the line fragment rect of the superclass, so it gives me where it thinks that rectangle of text that we're working on should be. And then I'm basically modifying it so that it keeps to this size of a circle, keeps into the boundaries of a circle. So it modifies the origin and width of that returned rectangle. Finally, unfortunately, to take advantage of all of this, you can't use Interface Builder. Not yet, at least. I have hopes. We all have hopes. So what you basically need to do is you create your container, you add it to your layout manager, which you've also created. You add your text storage to your layout manager, and finally, all together, wrap it into the text view. Now, this is the circular result that I got by making the change to the text container. The neat thing here is that I didn't have to do anything as far as how text is selected, how text is manipulated within this container. That all is handled quite nicely by Apple. They took care of all of that for me. I just had to say, hey, this is where work is getting done. It's also possible to do this using exclusion paths. I don't have an example for that, but it's even simpler. You basically are presenting a Bezier path to the system. You say, hey, within this space. So in fact, we could do this circular view by excluding kind of the outsides of the circle as opposed to the insides. So, a really neat feature of the fact that we went to iOS 7 and took nice control is dynamic type. If any of you went yesterday to the voiceover session, there was a really great discussion of it. I'm going to get a little more technical, but here you can see hopefully this is still true in iOS 12, I haven't played with it, but in at least iOS 11, under your settings, display, and brightness, which seems like an interesting spot to have it, there is this capability called text size, and that controls dynamic type. The fun thing is you can play with this little slider going up and down, so if you've got eagle eyes like many of my young developers, you have it slid all the way over to the left-hand side. And if you're more like me, you're having it somewhere in the middle. If you're like my dad, over to the right and then some if you could move it that way. Making use of dynamic type is super easy. Anytime you have a label or any kind of thing that contains text to it, you simply can select one of these text styles. You pick one of them, it automatically selects a size for you. If you're using auto layout, it's great. It automatically deals with a lot of this stuff. If you're doing it by code, and again, I hope you can see it, I don't know if from the back, but there's a new function to UI font called preferred font. And then you say for text style, and you pass in one of the styles, body or title or whatnot. And out pops the font. Now that font that pops out, it's really nice. It'll automatically change size when you play with that little, the little scroller. So this is what it looks like at, I believe this is the default size, and this is kind of the huge size, if you will. One of the things that I hadn't realized, and it's important to recognize, is that most of the Apple text elements, the UI text elements, will actually automatically change size. They're already doing dynamic type. So for example, that dynamic type element at the top is a header. I didn't set it to be dynamic type. I was kind of surprised to discover that it changed on its own, which was nice. It's always nice to get free code, but if your application is explicitly not using dynamic type, it's something to be aware of. Now, let's say you don't like San Francisco. San Francisco is a great font. That's what we saw there. SFUI text is the internal name for San Francisco. You can use UI font metrics. So basically you get your font metric for the specific style, and then you basically transform your font using font metrics, and it'll give you the scaled font. Again, that will automatically scale. When you use that font, it'll automatically scale. And so here, I applied the same sizing and so forth to Helvetica. You can see the two different sizes. Excuse me. So it's really nice. It's a very cool capability. There is one more feature which I found particularly useful. I hadn't thought of it, the need for it, until I actually came across it and went, oh, yeah, that makes sense. Which is the scaled value. Font metrics will give you the scaled value of any number, basically. So if you're creating a view, you have some text that's dynamic type, and you need something that'll keep, for some reason, in sync with that type, the same size or whatnot. Pass in the number, out pops the scaled version. It basically applies the same algorithm that it did to scale your font to your number, giving you the scaled version of it. Wow, this went a lot faster. So here we have, this is a section of the typography page over at the Apple site. This is really great. They provide you with the point size, the leading points, the tracking, and all that information, the weights and so forth, for the fonts in the preferred, for the preferred style. So you can see here all the different styles. Body has a regular, 17 points. This is something you can hand your designers to say, oh, okay, this is the font that you would get from preferred. What I did was I used actually the scaling information here and so forth to apply that to other fonts. So in my case, Helvetica or any other one, basically. So this is in the typography page, the Human Interface Guidelines. Highly recommend you check it out. They actually have here, if you notice, and it's not greatly rendered over here, but the small, the extra small, so forth, if you touch one of those, it'll give you the numbers. So it's really nice. That's what I use. Another thing to remember is to check off the automatically adjust font if you're doing it in Interface Builder. When you have a label or whatnot, text element, this will cause the element to change to scale automatically when you exit the app, change the setting for dynamic type, and then come back. Otherwise, your user will be very confused because they will have gone and changed it, come back, and it won't have changed. You'll be like, wait, what happened? I thought I had changed this. And it's like, no, it didn't update. That will cause it to change. It's really nice. This is basically the programmatic version of that. So if you're doing this by hand, if you're designing by hand, then you would adjust the font for content size category. And I believe this is a property that's essentially on every text element. Okay. Oh, and I have a highlighter. Finally, testing. Really important to do testing on this stuff. It's a great lead-in to doing multiple languages. Test the heck out of it. Now, here's the thing. In the accessibility inspector, there used to be this font size adjuster. I went looking for it last night, and I couldn't find it for some reason. It was really great while it was there, and maybe it's hidden somewhere. I haven't been able to find it yet. But the neat thing is you could have your simulator running, you connect the accessibility inspector to it, and you could just go, wee, and the font will go, wee. Unfortunately, I don't know if it's disappeared or just moved somewhere. I can't seem to find it. The net hasn't found it yet. If somebody knows where it is, please tell me because it's very useful.
Xcode 9.
Is it?
Are you looking at Xcode 10?
No, I was looking at Xcode 9.4.1, yeah. Although I did have the beta of 10 installed, so maybe it overwrote.
It's still in 10.
Is it in 10? I don't know, I didn't find it. But anyway, it's there. Good, so it's there. Very useful. This is great both for dynamic type as well as when you have multiple languages.
It's in the Xcode menu, open development tool, and it's right there. It's accessibility inspector.
Oh, the accessibility inspector is definitely there. No, this specific font size feature. No, the accessibility tool is definitely there. They haven't taken that away. That is a really useful tool. If you're doing any kind of accessibility work, highly recommend using this tool, by the way. It's very useful for doing audits and so forth to see how much of your stuff is accessible or not. But this specific font size feature, I haven't seen it. So if somebody comes across it, so it is still in there? I'm not sure why I didn't come across it. Anyway, very useful. Very useful to test this, to use this for testing out your accessibility as well as dynamic type. Yeah, so I'll come to my closing thoughts a lot faster than I thought. Hopefully I have good thoughts. The first thing is we're very much standing on the shoulders of giants. As you can see, the history of fonts just stretches back into kind of forever for us, basically, since we started writing. And we're benefiting from it today, and it's fantastic. But we just have to keep in mind that there is so much going on there. There's so much in that system. The other thing is flexibility and freedom. We are now, I think, arriving back to kind of that capability of calligraphy, adding all this kind of flair to the different characters, being able to lay them out, all kinds of different paths and so forth. The text framework, Cortex, as well as blanking from them, TextKit, are amazingly powerful. If you have an opportunity, I don't necessarily recommend diving into Cortex. If you need it, do it, but TextKit is remarkably powerful. It is in my opinion, getting to the kind of strength of like a PageMaker or some of these other very powerful page layout tools, there's a ton going on there. I touched on a few items, shaping things, but you can lay out text along any kind of path you'd like and that kind of thing. It's phenomenal. And the final thought there is don't be afraid to follow the white rabbit. You know, as I said, I kind of dove into this path, got into all kinds of weird stuff. You dive in and you discover all these things, and it wasn't something that I'm being paid to do, but it expands your mind, it expands your understanding of what's out there, what's been built, how it works, and that kind of stuff. And then you get an opportunity to potentially share it. If you create potentially something new out of it too, it's fantastic. So, yeah, that is my presentation. Went a little faster than I thought, but thank you all for coming. And yeah, we clearly have time for questions, so hopefully I can answer some if people have questions or not. Sir.
So occasionally I've heard people talk about using metals to do accelerated text rendering.
Yep.
I'm wondering where in the stack are you thinking about that? Is this
So I don't know explicitly where it's being used. I know that when there was the transition from TrueType to TrueType GX, that was the beginning of kind of using the graphic hardware to drive faster rendering of the different characters. I mean, if you think about it, these characters are basically, they're vectors. It's vector art. You're scaling, you're rotating, you're doing all kinds of stuff to it. So doing it at the metal level makes sense. I don't know explicitly. I believe it's under the Cortex layer. Cortex is reaching into metal.
Yeah, I don't mean now. I mean, so for example, iTerm, the terminal app, one of the recent versions said that they're now using metal to do accelerated rendering. And I was trying to understand, like, are they getting the glyphs out and then trying to render the vectors?
That seems like an awful lot of extra effort. I mean, I journeyed down that path just in kind of an experimental sense, just to see. I don't know. It seems like an awful lot of effort to manipulate the text when you can use things like core text and TextKit above it to do that work for you. I don't know about metal, how they're specifically, like I said, it seems like an awful lot of effort to control text. But I went down that little path. Somebody could have gone much further, and it makes sense. So I was like, okay. Any other questions? Yes, sir.
Sorry. So sometimes we get situations where a designer will pick a font size that is not in the dynamic set.
Yep.
On the enums. How do you work through that situation?
So that's when using the font metrics, UI font metrics, because you can set the base kind of default font size there. So, one second. Let's go back. So here, when you feed UI font metric a font, you can choose to feed, the font, the base font can be whatever size you'd like. So if you want to start at a much bigger font, right? But remember, that's your default size, what you're starting at. That's that baseline. And so you would basically say, instead of 24, I want it to be 48. And that would be your default. Just remember, it's going to explode when you go bigger. But yeah, once you do that and you pass it in to the font metric, it'll scale it based on what the user selected as far as what they want, big, small, so forth. Yeah, and like I said, the scaled value, very useful tool if you're not using auto layout, if there's something special you have to do to keep track with what is the size of things. Sir?
So, a while back, I was trying to get something to feel like it was text, to feel like it was vertically centered between 2 points.
Yep.
And we went down with this issue where the almost like the optical centering, because the centers and the decenters are like something different than fonts. And then that one changed in like iOS 4 or 5. It switched from what they call the legacy font metrics to now it's non-legacy font started doing these crazy things. So I was looking at a web page. I started doing these crazy things from like render it out to canvas and like, trying to figure things out. Is when you're doing a native app, is there somewhere I get the metrics on like
Oh yeah.
the senders and all these?
Yep. And off the top of my head, I believe UI Font has a good number of them. There is definitely, now I can't remember. It is possible to get all of that information, even down to.
Saner way of doing that than getting all of those metrics and manually adjusting things. I feel like I want to be able to just say center this where it normally considers to be centered, not centered.
Yeah, no, unfortunately, there's all kinds of magic being woven into fonts to make them look optically correct, if you will, that isn't so much a specific like measurement that you can do. An example would be the letter O goes above the line, basically, above the top, basically. Anyway, it dips a little bit below, it goes a little bit above it, and this magic occurs basically because otherwise it looks optically wrong. Like you'll look at it and you'll be like, there's something wrong here. So font designers are weaving a good deal of magic as they're making these. And there isn't a great mathematical algorithm that you can say, no, make it center. It seems that it really is kind of designers have to weave their own magic into like, okay, let's move this just a hair that way. And that's why you get things like kerning becomes important, where you start playing with the distance between different characters and how they might kind of slip together. And ligages, of course, also make fun, that kind of giant swoop we saw in the Z of Zapfino. All of that it's exciting, it's very cool, but it also is very difficult when you're trying to kind of bring it down quantitatively to like math and go, I want to make it. It seems to require really just designer eye to go, okay. It's like, oh, that's 23.5. You're like, no, 23.5. So, sorry. Any other questions? Okay. Well, thank you all very much for coming. Really appreciate it. And again, thank you very much.